2025 has been a huge year for quantum computing, and yesterday Microsoft announced their new quantum processing unit, the MAJORANA 1. This is a huge breakthrough for quantum computing. Before we continue talking about what MAJORANA 1 is, I'm just going to explain a little bit what quantum computers are and what are the problems that we are currently facing with them. Well, classical computers use electrons to do computations, and as you probably already know, computers use zeros and ones to represent data and do computation. We call them bits. Since the 60s or the 50s, we've been able to exponentially increase the computation power of the classical computers. We started with the vacuum tubes, and then the transistor got invented, and then transistors got really small into microprocessors, microcontrollers, and what we currently have, supercomputers. And in the last 60 years, we have been able to achieve extraordinary things. We've been able to solve huge problems, but there are limitations. There are problems that classical computers can't solve, and it will take them decades or even centuries to solve them. Even if you gather all the computers and supercomputers and put them together, you won't be able to do it in a reasonable amount of time. And this is where quantum computers come in. Quantum computers use qubits to represent data, store data, and do computation. There is a concept in quantum mechanics called superposition. At a high-level view, it states that a particle can have multiple states at the same time. So it means that qubits can be zeros or ones or a combination of both at the same time. This is just a high-level view, and I'm not going to go too much into the details. Now, this is also the case for every other qubit in your system. So which means that you have even more computation power because you can represent more data, more combinations in your system. But there is one major problem with quantum computers, and it's noise. Qubits are really fragile, and the environment around your quantum system can distort your qubits. So you can have error or loss in your data, which isn't good. There are some solutions to this. There are some companies like Google and IBM that use supercooled environments for their quantum systems, which minimizes the noise around the quantum system. Microsoft's approach is to use what is called topological qubits, which rely on Majorana particles. The idea is that if you encode information in these Majorana modes, it becomes way more protected from errors because the quantum system is kind of braided into the system's very structure rather than exposed on the surface. So you reduce noise. Why does that matter? Because if we can make stable qubits, we can start building bigger quantum systems without everything falling apart. Quantum computers could tackle huge problems like breaking modern encryption, designing new drugs or materials, and modeling complex phenomena in physics. Now, Microsoft's claiming that their new chip can have up to 1 million qubits, which is huge, and we've never seen this before. The most qubits that a system has ever achieved until now has been around 1000 qubits. Now the real question is, can it really achieve 1 million qubits? And when are we going to see a stable quantum computer? I'm gonna make another video explaining the Majorana 1 in more details, and I'm also gonna make another video explaining quantum computers in more details. So if you're interested in these kinds of videos, don't forget to subscribe and enable notifications so you don't miss these videos. Thank you.